Okay, why is this all important? Because we've got to do math with all the numbers we have in our laboratory. So there is a rule for adding and subtracting, and there is a rule for multiplying and dividing. Let's take a look at these two math problems here. Let's say these are measurements. Let's say this is centimeters that we're dealing with here. We've measured these things and we've got centimeters. Once I put these units here, these are not exact numbers. They are measurements. They're something we did in the laboratory to measure. Now in math class, of course, you would just like do this and put a little zero and now you could add. But here, you can't do that. Because remember, this 7 is your estimated digit. That's your estimated digit. You have no idea what this number is at all. You have no idea what that number is at all. You can't say it's a 0. You don't know what it is. You cannot add this question mark and this 3 together. You can't do it. So all you can do is ignore the 3 and add from there. 9.912 centimeters. Same goes here for subtracting. Once again, I don't know what this digit is. The 3 is my estimated digit. So I don't know what this digit is. I can't subtract 1 from a question mark. So I can get rid of that 1 altogether and subtract from there. 4.212 centimeters. You'll notice these guys over here, those really are zeros. Okay? 1 plus 0 is 1, or 0 from 1 is 1, 0 from 2 is 2, 2 plus 0 is 2, 1 plus 0 is 1. Those really are zeros. But these guys out here, I don't know what they are, so I have to ignore them. The rule for multiplying and dividing, the answer can only have as many as the least number in the problem. Let's take a look at this one that I've made up here. In 5,230, according to my rules, there are 3 significant figures there. That 0 does not count. In 2,000, there is only one significant, 200, there is only one significant figure because, again, there's no decimal point here, so there's only one significant figure. In 56, there are 2 significant figures. So my answer can only have one significant digit. This is why it's so important when you're in the laboratory to take as many significant digits as you're allowed. Because you don't want to do math with one significant digit. It really limits your answer. But I have no choice here. There is only one significant digit here. I've put those zeros in to represent the fact that this 2 is really 200 and not 2 or 20. But they're not significant. I don't know that they're really zeros. I had to round to get to 200. So I cannot put more digits in my answer than I have here. So if I pull out my calculator and I do my math here, 5230 times 200 divided by 56, my calculator gives me 18,678.57143. But all those digits aren't real because I don't have enough digits to write all that down. I only have one significant digit, so the only thing I can write is 2 times 10 to the 4th, or 20,000. I know it kills you to get rid of all those digits, but the key important point here is those digits aren't real. There was too much estimating going on in my numbers here. Those digits aren't accurate. If that 200 was really 220, I would have a totally different answer of 20,546. So the only number I can really be sure of is that 2 at the beginning. 2 times 10 to the 4th. That's why I have to write it like that. And please don't tell me it's 2. You have to put the 2 times 10 to the 4th there. All those zeros, they matter. 2 is not the same as 20,000. Of course, you have to take into account units also. So if I had something like 4.3 centimeters times 2.2 centimeters, 4.3 times 2.2 is 9.5, and my unit would be centimeters squared. Yes, the calculator gives you 9.46, but there's only two significant figures here and 2 significant figures here, so there's only 2 significant figures in the answer. By the way, when it comes to rounding, we do have an extra rounding rule here that you do not do in math class. When you are rounding, most of the rounding rules are totally normal. If you have something that's a point, 3.4, you would round that down to 3. You have something that's 3.7, you would round it up to 4, all the things you're used to. But what if you have exactly 3.5? It's not closer to 4 or closer to 3. I know you've been taught in math class to round up, but here we're a little more rigorous about our numbers. Essentially, it's a statistical thing. If you have a lot of numbers and you consistently round up, that will actually introduce bias into your figures. So what we really want is essentially half the time to round up and half the time to round down. That way any errors made by rounding get canceled out. So the rule is, when you're rounding and it's exactly 5, go to the even digit. Okay? Go to the even digit. So 3.5 gets rounded to 4. 2.5 will get rounded to 2. So this one went up because 3 is odd and 4 is even. This one went down because 2 is even and 3 is odd. Go to the even digit. That's really rare that happens. It only happens if this that you're rounding and getting rid of is exactly 5. If this was 2.51, you're closer to 3 and you would go to 3. But if it's exactly 5, head to the even digit. That's everything you need to know about significant digits.